everybody, welcome to part 2 of converting Denary to binary system. If you didn't watch part 1, you can go back in the playlist and you'll find it. Watch that video before coming to this one because that's when you understand the remainder system better. So, without wasting much time, let's start. So, the remainder system is much more general system. Let's convert a number like 83. So, for the remainder system, this time you draw your table vertically and the columns will add themselves. You don't actually need to know the number of columns beforehand, just draw the table. So we have 83, and this system uses successive division. If you don't know what successive division is, in simpler English, it's just repetitive division with the same number. So 2, that's the number we're trying to convert to. We're trying to convert to base 2, which is the binary system. So we use 2 for the successive division. So let's start. 2 into 83. You can just say 83 divided by 2 quickly. So 2 into 8 is 4. 2 into 3 is 1. Remainder 1. So you have 41, remainder 1. So the answer, you write it here, 41. And what do you remain with? 1. Then you again divide by 2. That's why it's called repetitive division. And you see the columns will be building up themselves. So 2 into 41, you divide the 41 here. 2 into 41 is simply 2. 2 into 1, it can't, so it's a 0. Remainder 1. So your answer is 20, remainder 1. Continue. 2 into 20 is 10. I don't need to write that one out. And what was the remainder? 0. You didn't get any remainder because 2 divides into 10 evenly. 2 into 10, you get a 5. Remainder 0. Nothing. And as you can see, the remainder column is only having a 0 or a 1. A 0 or a 1. 2 into 5, it is 2. Remainder 1. 2 into 2, it gives you a 1. Remainder 0. 2 can go into itself without giving a remainder. 2 into 1, 2 can't go into 1. So the answer is 0. Remainder the 1. Yeah, this concept gets confusing, but why are we getting a remainder of 1 but when we just divide it 2, which has no remainder? Well, simply because if you know how remainders work. So remainders are just the number which you should add up in order to get the original number. So like in the case of 83 here, when we divided it by 2, it gave us a 41. That 41 doesn't give us an 83, but when we add with the remainder, it gives us the answer. So what I simply mean is like, so 2 into 83 gave us a 41 and a remainder of 1. So when you multiply these 2 times the answer you got, it gives you an 82. And use the remainder to get the final answer. And that gives you the 83 back. So in the case of 1 here, you say it's a 0. So you say 2 times 0. And the answer is 0. To get the original number back, you add a 1. So that gives you the 1 back. That's why when 2 divided into 1 is actually 0, but the remainder is 1. Because when you multiply 2 against the 0, it gives you a 0. Add the remainder, it gives you back the 1. Now we can continue. 2 into 0. Well, 2 can't go into 0. 0. Remainder, it didn't go into 0. And that's 0. So when you see that you get a 0, 0 here, then that means the process has ended. So now you read your answer from bottom to top. Make sure it's always bottom to top. Don't read it the other way. So the answer, you start with the 0 which is here. If you want, you can avoid it, but you can start 0. You get the 1 which is followed there. 1, then a 0, a 1, 0, 0, 1, 1. And that's 83 into binary system. So that's the remainder system. The reason why I said the remainder system is more general is because imagine we're trying to convert to base 3 now. We can just simply replace these 2's with 3's and keep on dividing. The answer you get is that number in base 3. That's why. For the trial and error method, you can also do that, but as you know, most of us don't know how to add 3 repetitively. So yeah, no time for that. So if you are trying to convert to any other base, I would advise you to use the remainder system. Some of you are already saying, whoa, he's teaching us things which we already know. But don't worry, you'll see the importance of learning these things. So let's convert another number. The other number we'll use is, let's go to bigger numbers. We like bigger numbers. 221. 221 is big, but with the remainder system, it will be easier. 221. 2 into 221. So if you don't know what 221 is divided by 2, don't worry, we are the same because I also don't know. So 2 into 221 is 1 there, a 1 there, 2 into 1 cancel, 0, and the remainder 1. So it's 110. Nice. So 2 into 221, it gives me a 110 here. Remainder 1. Oh, sorry. If you think that's a 1 there, that's a 1 there, and that's a 0 here, not a 6. So, whoa, I also don't know what 110 is divided by 2. So 2 into 11, you get a 5. 2 into 10, you get a 5. Remainder 0. No remainder there. So 55, remainder 0. Then you continue. 2 into 55, it will give you, let's divide, just for clarity. 2 into 5, 2, remainder 1. 2 into 15, this will be a 7, remainder 1. That makes sense. So 27. Continue dividing, remainder over 1. 2 into 27, I think I know what this one is 13, remainder 1. 2 into 13, it's a 6, remainder 1. 2 into 6, it is 3, remainder 2 into 6 is 3, remainder 0. 2 into 3, it's 1, remainder 1. 2 into 1, it is, as I stated earlier, 0, remainder 1. And if you continue down, sorry, my whiteboard has ended. If you continue down, it gives you a 200, which we know is the termination signal. So the answer is 1 1. Read it from bottom to top. BT 1 1 0 1 1 1 0 and a 1, and that's your answer. Nothing else. So that's 221 converted to the binary system. I think that will end our lesson. Let's convert, for the last example, let's convert a smaller number. So we'll convert, we haven't dealt with any small numbers. We've only been dealing with big numbers like 83. Let's use a smaller number now. So the candidate for a smaller number will simply be, we can just add on this table. The candidate for a smaller number will be, what's the date today? Let's use 3. 3rd of May today. So 3rd, 3 there. So you say 2 into 3, it is 1. Remainder 1. 2 into 1, it is 0. Remainder 1. 2 into 0, and you get a 0. Remainder 0. So your answer is 0 1 1. That's your answer. That's 3 converted to base 2. Nothing else. That's the answer. So with that, I think it's a wrap of using the remainder system. If you want to try out bigger numbers, I'll post the exercises in the group. I want people to know what to convert ternary to binary, and for people to learn why a computer is needing the binary system. Thank you for watching. Please leave a like and subscribe to continue with this computer course. Don't worry, by the end of this course, you know what a computer is.